So this is what in class we call the triangle problem. If you really want to look it up, it's a Knuth's up arrow notation, if you want to Google that. But we don't need to worry about that. So in class we called it the triangle problem, and for rule 1 we drew it like this. We said A0 B is A plus B, and then we had another rule. We had this rule. We had X n1 is X. So what that meant was, as long as there's a 0 at the top of the triangle, you add the other two parts of the triangle, and as long as there's a 1 in the right-hand corner, you take the left-hand corner. And the first rule took priority over the second rule. And finally we had one more rule that said, if that situation didn't apply, so for example P, N, Q, then we would do the following. We would put a triangle inside a triangle, and there we go. So we would put P, N minus 1, and then another triangle. But inside the second triangle we'll put P, N, Q minus 1. And that is the rule. That is the rule we use most of the time. Okay, so explain how to simplify the following problems. So the thing you would do for triangle 2, 1, 3, so question 1, is you would go ahead and use a triangle notation if you haven't figured this out yet. So you would say 2, 0, 2, 1, and 2. And I have a separate video about this, so I'm not going to go into great detail about this. But then you use this triangle. Okay, and then that triangle is 2, 0, 2, 1, 1, and that is 2 plus 2 plus, and then this inside triangle, so I'm going to write it this way. This triangle is another 2, so the answer is 6. Alright, so that's a perfectly acceptable way to write the answer to number 1, provided if you didn't explain the shortcut, then that's what you're going to write. And question number 2, very similar. 3, 1, 4 is going to be, and I'm going to write this second triangle because I'm getting tired of writing triangles. I'm just going to, don't know why I'm having trouble making triangles. I'm just going to put a line there to indicate 2 triangles. So this is 3, 0, 3, 1, 3, and we're watching this. We could even think of it this way. Three, 1, 3 becomes what? It becomes 3, 0, 3, 1, 2. Aha, we're kind of nesting the triangles. 3, 0, 3, 0, 3, 0, 3, 1, 1, and then that answer is 3. So this is a 3, and then we're adding 3, 3, 3, which is 12. Hopefully you're starting to understand why nesting these guys is the same as multiplication. Because if you start out with a structure like this here, then you're going to keep extruding another 0 and another circle until such point as we trigger the second rule right there. Okay? So you need to give some kind of explanation for why the following is true. Okay? if you want to use shortcuts, you have to explain the shortcut A1B is AB because A1B is actually, why am I having trouble with the triangle feature? Okay, is A0, A1, B minus 1. Okay? And this means AB is, okay, I should say, is really saying AB is A plus A times B minus 1. So the point is, the reason why there's a relationship that allows us to just say triangle A1B is A times B, it's because we're making use of the way addition, multiplication distributes this way. I'm sorry, addition. So we're multiplying. Let's look at the algebra. So these guys cancel, right? So this is really an inductive proof, which we haven't talked about in class, but it's such a simple inductive proof that let me just explain this. If the bottom case is correct, right? If this is true, which it is, then this has to be true, which it is because this is true. This is A0, I'm going to use the rule, A11, and then it's just going to be A plus A, which is equal to 2A. Okay, so if this is true, then we're gonna adjust this a little bit. We're just gonna say, well, if this is, say, K, then this is gonna be K times A. It's true because if K keeps becoming 3, 4, 5, and so forth, this is true because, so this is essentially what it's saying. Since, let me pause this to write it to save some time. Okay. Since this previous triangle, so we started with the base case where this corner was just a 1, and so this equals 1, and I erased that. But now we can keep hiking it up. We can show that since it was true when K was, say, 2, then K can be 3, 4, 5, whatever you want it to be, and it keeps going up. So we're showing that if this is true, this is a previous case, that we can nest them because this big triangle with A1K can be broken down as A0 new triangle, but we knew the new triangle is already A times K minus 1. So that means if we add another A in, then we're just hiking this up to A times K. Alright, so hopefully that will help you understand. So this is more explanation than I expect you to give, but that's one formal way of explaining it. Okay, so I would expect at least some kind of explanation from you about why this works. You can say, well, because the triangles keep telescoping or nesting all the way down, and the number of triangles that are nested is equal to B, and then the very last triangle is just going to be equal to A, so we're adding up B copies of A, and so that's how we got multiplication. So there's a lot of different ways of doing it. It doesn't have to be perfect. I'm looking for some plausible explanation that is, so here's my standard. I'm not asking it for you to be as good as, say, a mathematician. I'm expecting you to have an explanation that's good enough that you could convince one of your classmates who was absent or somebody who was struggling with the homework. That's my standard. You have to be able to convince a classmate in a fairly accurate way. So if you leave out a couple details, but they're kind of obvious, then that's okay. All right, so then what about this explanation? What is going on here? So we don't know what's going on here, but, I mean, I do, but what I want you to do is say, well, it really looks like what? You subtract 1 for the peak, and then these guys you recopy, and then we get down to our special case, so it's just 2, right? So there's just a 2 there, so this is equal to triangle 2, 1, 2, which we know is 4 because we already explained the multiplication deal. So you don't have to explain the special thing that that 2 does, provided you write out the steps. If, on the other hand, you say, oh, the power, this 2 is just turning this into an exponent, so this is 2 to the power of 2, where the first 2 is on the left-hand side, so it's this 2 to the power of this 2, so it means, okay, let me cut this here. So this means 2 to the power of 2, and it's blue 2 is causing you to take the left corner as the base and the right-hand corner as the exponent. You can say that, but then you have to explain, just similarly to the way you had to explain before. You could say, all right, a to b is a to the b because, okay, we can start with the base case. Let's see. A to 1 is equal to a, right? So a to 1 is equal to a to the power of 1. That seems really silly, right? But now they can nest. We can nest them just like we did before, and we can say, well, a, let's do another example. A to 2 is A1, A to 1, and in the same way we had these telescoping triangles, this is A times A, which is A squared. So this is going to take more paper than actually just doing out the problem, but I thought I should show you. So then you'd have A1, A1 again, and then A2, 1, which is just going to be A cubed, and so forth. And so if you give me a verbal explanation that each time you increase this number here, you're getting one more nested triangle, and so since it's all multiplied, because these guys multiply everything together, and this is the only exception because this is already equal to A, so it's A times A times A. If you give this whole explanation, then you can just answer 3 and 4. But probably it's easier to just go ahead and do those ones out. So it's probably most strategic to actually explain how this 1 is going to turn everything into multiplication, but not bother with the explanation for how the 2 turns everything into exponentiation, because it's just faster to do those ones out if you can draw triangles without messing everything up. Okay, 5, 1, 5, 2, 2, and then you could do something like this. 5, 1, 5, 1, 5, 2, 1. So that's 5 cubed, which is 125. Okay? So hopefully one of those explanations will make sense to you.